Now with this, we're going to look at some different ways to solve quadratic equations. The video from the Think Well material, he talks more about quadratic functions and graphing and that type of stuff, but I want to kind of go to the quadratic equations and how we solve that. We're going to be solving lots of quadratic equations within the semester working with calculus. Now, to me, the easiest way, and for most students, solving an equation like this, we set it equal to 0, and then we try to do what? Okay, factor. Well, to factor this, we'd have, I think most of you could probably do this quicker than me, but is that right? Make sure. Then, what do we do with the factors? Okay, set both equal to 0. Now, do you know why we do that? If we have a product, if we have a product that is equal to 0, what do we know about one of those two numbers? Okay, if A times B equals 0, then either A equals 0 or B equals 0. And formally, we call this the zero product property. Does that work for any other number? Say we have A times B equals 1. Does that mean A has to equal 1 or B has to equal 1? No. With that example, A could equal 1, then B would have to equal 1. But for a product to equal 1, A could be 2, but then B would have to be 1/2. So neither one of them has to be equal to 1 if A times B equals 1. The only number that works for is 0. And that's why we can solve this by factoring and then setting each factor equal to 0 and solving. So we'd get x equals 3 or x equals -2. Now, what's another way of solving an equation like this?
Quadratic formula?
Yeah, the quadratic formula. Now, instead of going through that, I'm going to show you where the quadratic formula comes from. And to be able to, I want to show you one other way of solving an equation. If we have x squared equals 4, if we have the perfect square, okay, we could say x is going to equal what? Okay. Now, not just the square root of 4, but positive or negative square root of 4. And that actually, we're kind of jumping over a property in mathematics that we do need to discuss here. When we square root both sides, technically the square root of x squared is not just the value of x. Technically, the square root of x squared is the absolute value of x. Now think about that. If, we'll kind of put that on the side burner for now. If x equals, say, 2, going along with our square root of 4, if x equals 2, then the square root of 2 squared, square root of 4, is 2. So, yeah, there we can say square root of x squared equals x. But if x equals -2, square root of -2 squared is not -2. Square root of -2 squared is positive 2. So in this case, the square root of x squared is not equal to x because x was negative 2. Square root of x squared would still be the absolute value of x. Absolute value of negative 2 is 2. So technically, the square root of x squared is the absolute value of x. Now, next page, I'll have to... The square root of x squared equals the square root of 4. So technically, we would have to say this would be the absolute value of x equals, well, square root of 4 is 2. And then the absolute value equations, the absolute value of something can be either the positive or the negative value. So we would say x would be positive or negative 2. So when we start out with this, x squared equals 4, we normally jump over this step right here and go directly to saying x is positive or negative square root of 4. Okay, so we need to keep that in mind. To kind of go beyond this, if we have something like this, can we use that square root property? Take the square root of both sides and applying that absolute value property as well. The square of something equaling 4, the inside, the x plus 3 this time, will equal either positive 2 or negative 2. So we get two different equations, and we find our two answers. Subtract 3 from both sides, we get negative 1, or x could be negative 5. Okay. Now this is the idea we're going to use to develop the quadratic formula. So let's see what we need there. The idea comes from being able to square or to have a perfect square binomial, that x plus 3 quantity squared. Okay. And there's a nice little procedure. To be able to use the square root procedure like we did in the previous problem, we've got to write this somehow as the square of a binomial. And that process is called completing the square. Now, for that to work, the coefficient of x squared needs to be 1. And we really only need to deal with the x squared part and the x part. So let's first move the c over to the other side. And then to get x squared to have a coefficient of 1, we need to do what to both sides of the equation? Okay, divide both sides by a. So, and then separating each of these with a as the denominator, a divided by a will end up with x squared plus, well, our second term will be b over a times the x, and that's going to equal negative c over a. Okay. So now we've got to look at this and say, how do we complete that square? So from this form, The procedure of completing the square is to look at the x coefficient. Now, with numbers, this is a lot easier to look at, and I'm sure most of you have done this before and can do it and nothing flat, but with letters it's a little harder. We take 1/2 of this coefficient of x, what I usually call b, but now that coefficient of x is b over a, so 1/2 of that coefficient, and then what do we have to do to that? We have to square that quantity. Okay. So 1/2 of b over a would be b over 2a. I'll go ahead and write that part in there. That's going to be an important part of the final form here. And then squaring b over 2a, we get what? Make sure we square 2a, b squared over 4a squared. So what we do with completing the square, we add that to both sides of the equation. Come on. And then, this part right here, because of this procedure of completing the square, this will be able to factor into what? This is where this part of the process is very helpful when we have ugly expressions like this, or maybe fractions. If it was, say, x squared plus 4x plus 4, we can look at that and know what it factors into, x plus 2 quantity squared. But with this, it's going to be the x plus whatever this expression is before we square it. So this x squared plus b over a times x plus b squared over 4a squared factors into x plus b over 2a quantity squared. And that's going to equal, well, we're probably going to have to do something more with this side. Any questions up to that point? Next, the procedure would be to combine this into a single fraction. What's your least common denominator here? We've got a and 4a squared. Well, 4a squared is going to be our least common denominator, so we're not going to have to change the second part, but the first part we're going to have to put as what? We need to multiply by 4a, top and bottom. So we'll get a negative 4ac. Okay. And then replace that. We have our common denominator of 4a squared, and we'll have negative 4ac plus b squared on the top. Or what we would normally, the normal order we would put this in, b squared minus 4ac all over the 4a squared. And now you can kind of start to see where that quadratic formula is coming from. What would we need to do to this equation now? Okay, square root both sides. And we'll go ahead and do the absolute value property as well, what I like to call the shortcut. We'll have both the positive and negative square root of this side. And almost done. We've got to simplify the square root as much as possible. Well, the numerator, we're not going to be able to simplify it all, but the denominator will simplify to what? Okay, well, this denominator, square root of 4a squared, would be simply just 2a. So as we rewrite this, unfortunately there's not enough screen to do much of these. We have x plus b over 2a equals, in the numerator we'll have our square root of b squared minus 4ac, and our denominator simplified to 2a. And so now to solve for x, we do what? Subtract our b over 2a from both sides. And since we're used to seeing that as the first part of the quadratic formula, we'll put that in there. And I think I lost something at the beginning. Don't forget that plus or minus in there. So our quadratic formula, instead of seeing it as two separate fractions, we do have the common denominator of 2a. We say the quadratic formula is negative b, well, technically we really should say the opposite of b. The opposite of b plus or minus the square root of the quantity b squared minus 4ac all over 2a. So that's where the quadratic formula came from, and it goes through the procedure of completing the square and then taking the square root of both sides, which I'm sure you've done a little bit. Some of the easier problems we take the square root of both sides, but with a really ugly looking equation like ax squared plus bx plus c equals 0, going through completing the square is a lot harder than just remembering this formula right here. So that's the what we call deriving the quadratic formula, and since we've done that now, instead of having to do that over and over and over again, we can just remember the quadratic formula. I think most of you know that already, right?